Whew. Being a water resources engineer sure is tough. I'm sorry to keep you waiting. Let's start. Good day, curious individuals on the internet. By any chance, have you given any curiosity towards what exactly is a water resource engineering? Then, if you do, you're in the right place. Since me and my fellow engineers will bring you through topics concerning about the following. First is water resource engineering definition, which will be discussed by Engineer Julyanna Montes. Second will be the history of water resources engineering, that will be discussed by Engineer Niña, Alyannah, Kaye, Regidor. Next is the kinds of water resources engineering, that will be discussed by Engineer Esparcia. Next will be the importance of the water resources engineering, that will be discussed by my fellow engineer Jim Richard Gatchalian. And the major functions of water resources engineering will be discussed by yours truly, Engineer Bejona. And lastly, the applications of water resources engineering will be discussed by Engineer Fleuramor Baraclan. Now that the introduction is out of the way, let's go and discover what water resources engineering actually is.
What is water resource engineering? Water resource engineering is a study and management of equipment, facilities, and procedures used to manage and maintain life's most abundant resource. They are frequently involved in water management to ensure that it is safe to drink for humans, plants, and animals. They assess how the best way to control water as it pertains to water-related activities such as irrigation, water disposal, and canal development. This is a field of engineering that is primarily responsible for water, and it tackles the planning, development, and management and estimation of water resource. They are also the ones who design of hydraulic structures such as sewage conduits, dams, and breakwaters, the management of waterways such as erosion protection and flood protection, and environmental management such as prediction of mixing and transport of pollutants in a surface area. They may also involve in water treatment to enhance the quality of water for a wide range of end uses, including recreational, commercial, and industrial. They also fulfill a wide variety of roles in designing and managing water-based systems. That's all for the definition of water resource engineering.
I hope you don't mind me read French books while you discover what water resources engineering is. But besides that, now that you have the foundation on what water resources engineering is, let's proceed and go deeper with our knowledge on the water resources engineering history.
I am Alyannah Regidor, and I will talk about the history of water resources engineering. The advancement of human civilizations from the old time frame depended on the accessibility of water assets. Various civilizations succeeded when the accessibility of water was high, and it folded when the water got drained. In the view of archaeological proof at Mohenjo-Daro, it was being discovered that around 3000 BC, individuals in this valley had great information on groundwater improvement through wells. During this period, the Moses Dam was built across the Nile River. A portion of the sources even say that it was utilized to gauge the progression of water in the Nile River. Around 300 BC, Aristotle expressed that all rivers come from the precipitation and gets gathered beneath the outer layer of the earth, and arises when the water amount increments later during the civilization advancement. Individuals learned that numerous standards of hydrology and began to develop scaled-down dams, supplies for putting away water. In the late 14th century, Leonardo da Vinci was the main individual who expressed the standards behind the stream in open channels. In 15th century, Bernard Palissy said that precipitation was the main wellspring of water for springs and waterways. Da Vinci and Palissy gave the possibility of water cycle, additionally alluded to as the hydrological cycle. The advanced investigation of hydrology began with investigations of Perrault, Marriott, and Halley in the 17th century. Pierre Paris was the first to propose the idea of precipitation estimation by water balance, condition, and catchment region strategy. Halley estimated precipitation of the Mediterranean Sea. The instrument that was used by him is still not known. 16th century acquired various advances, water-powered hypothesis and instrumentation. Piezometer, petatube, Bernoulli's hypothesis, and Chez's formula were developed. In the 19th century, massive advances were made in the instruments for getting groundwater, precipitation, amount of runoff, and computerized offices for the information examination has upheld to the area of hydrology inconsistent development rate. From the arrangement of encounters, clearly, hydrology has its importance in various fields, relying upon which it is portrayed into different divisions. In engineering, it manages a review identified with engineering applications. For example, water resource estimation, the measure of application, measure of spillover, and the investigation of issue identified with water. And that's the end of the history of water resources engineering.
Oh, I was just interested in the history of water resources engineering. Don't mind me take notes. But now that you have known the history of water resources engineering, let's try and see the different kinds of water resources engineering.
There are many kinds of water resources engineering. Well, for now, I'll just give three. Groundwater, hydrology, and hydraulics are the three primary categories that compose water resources engineering. Groundwater engineering, or also known as hydrogeology, is concerned with the modeling and management of subsurface water as well as the design of extraction methods. Hydrology engineering is the one that studies the occurrence, distribution, flow, and qualities of water on the surface of the earth, beneath the surface of the earth, and in the atmosphere. The physical, chemical, and biological interactions of water in natural and man-made environments fall within the domain of hydrology. Hydraulics engineering is the one that addresses the control and management of water resources. Hydraulic engineers work with our water resources to create, control, and manage them. Surface runoff, stream flow, droughts, floods, groundwater supplies, and future water demand are all predicted. Engineers in hydraulics also choose reservoir locations for improved water supply, maximum flood management, and hydroelectric power plants. To limit lake and river erosion and promote marine traffic, such engineers build river and coastal projects.
Oh, you're actually done. So that was a very great presentation by our fellow engineer on bringing you the different kinds of water resources engineering. And now that you have known the different varieties of this type of engineering, let's proceed and know the importance of water resources engineering for our society.
As they said earlier, we water resource engineers are responsible for solving problems associated with transporting, cleaning, and protecting one of our most valuable resources, which is water. Resources by their very nature are finite, we all know that. There are only small handful that are naturally renewable, such as wind, solar, hydro, and biomass. While water may be renewable in terms of many different ways, it can be used and reused. It's not as abundant as it once was, which many earth scientists and climatologists point to as a function of climate change. Fresh water on the land surface is a vital part of the water cycle for everyday human life. On the landscape, fresh water is stored in rivers, lakes, reservoirs, and creeks and streams. Most of the waters people use every day comes from sources of water on the land surface. So, in the broader field, we water resource engineers advise on sustainable use of resources by conserving water, building dams, and conveying water to users. Our planning ensures holistic and integrated management of water which balances the needs of nature with those of users. So the importance of water resource engineering is to preserve freshwater resources and find new ones. As I said earlier, there are only 3% of reusable water here in planet. And it is now gradually decreasing because of some factors like climate change, increasing vulnerability to severe weather events, growing urban demand, over allocation of existing supplies, unrestricted extractions, land use change, and environmental requirements. So because of this, we are having water crisis. So here are some water crises in the Philippines that we need to give solutions and actions. Please watch this. We need more water resource engineers to make more dams that restore water and give sanitation to the users. By this, it is possible to us to decrease or even end this water crisis that really affects a lot of our fellow Filipinos. So, if you want to be a water resource engineers that will help our society, please be water resource engineer.
I actually agree with a lot of points stated by Engineer Gatchalian towards the importance of water resource engineering to our society. And now that we have established that knowledge, we can now proceed to the functions of water resources engineering. And it will be discussed by yours truly. Water resources engineers, as you may know from my fellow engineers, place a range of responsibilities in the design and management of water-based systems, designing major water distribution systems that transport water to water users and collection systems that transport waste and storm water, managing surface and groundwater resources, metering and quantifying flows in rivers and streams, modeling and designing major water resources projects, and many other water-related engineering functions are among these responsibilities. To work in public and commercial sectors, water resources engineers are needed to have these following skills: planning and designing water distribution systems, sanitary and stormwater collection systems, and the pumping and storage infrastructure required by these systems. Designing highway drainage systems and conveyance structures such as culverts and bridges. Managing floodplains and municipal streams and developing floodplain maps and management plans. Managing rivers and reservoir creation, flood control, irrigation, and other multi-use functions. Developing groundwater resources and remediating polluted groundwater resources. Designing the hydraulic features of new hydraulic structures such as dams, locks, hydroelectric stations, levels erosion control, measures, and many more other applications. Water resources engineers advise the sustainable use of resources through saving water, constructing dams, and transporting water to consumers in a larger sense. They also provide holistic planning and integrated water management that balances both the demands of the environment and its users. And now that you have known the major functions of water resource engineering, let's proceed to its applications towards society.
The application of water resource engineering lies more in solving the problems of the society which involves water. Some of its applications are the community water resource like dams and breakwaters, sewage system, and the waterways management such as erosion protection and environmental management. Everyone in the world needs water. We all use water daily. We use it to wash your clothes, to wash the dishes, to drink water, and to provide your body with the right amount of water, and to take good care of our personal hygiene like taking a bath or brushing our teeth or simply doing our recreational activities in the water. Therefore, it takes a lot of work to take good care and to have a good quality water, and it is the job of the water resource engineer to provide the community with a good quality water.
As a water resource engineer, we focus more on improving water quality, taking care of the environment, and making sure areas are protected by floods through dams and coastal and river defenses. With custom solutions, we make communities stronger and better able to resist harmful environmental, economic, and social impacts.
So you see, water resource engineering coincides with environmental engineering. This is because water is a part of the environment and it is also needed to be taken good care for the consumption of everyone.
Oh, I actually learned a lot of things regarding water resources engineering, and I hope you too have learned a lot of things. And I hope you would retain this information so that you would be able to give importance and value to different projects made by water resources engineers. Then, I have a phone call. Clearly. Hello? Hmm? Oh. Okay, I'll be there. Alright? Sorry guys, there seems to be a problem on my workspace, so I gotta go early and cut this presentation off. I hope you've understood a lot of things like what I said earlier, and I gotta go now. See ya!